In this section, we're going to talk about the stomach. So the stomach is actually kind of interesting in the way that it is designed. Remember that there's going to be a lot of acid that is going to be used in digestion when it comes to the stomach. So we actually have to have that stomach lining that is going to be designed to secrete that acid. That's our parietal cells here that are actually going to be our acid secreting cells. And we're going to have it, you can see it's kind of a thick relatively cell structure and lining of that stomach. It's also very muscular. So we're going to have a lot of churning that's going on. And again, we're probably not going to feel that most of the time, although sometimes you can kind of feel things moving around a little bit. But you're going to see that there's actually a lot of different muscle structures here. So we have an oblique, a circular, a longitudinal. So our muscles are actually going in a number of different ways to help us with that churning and to help our stomach be really strong and thick. So what happens in our stomach? Well, we're going to create this substance called chyme. And at this point, it's really not going to be food anymore. It's chyme. So our chyme is a mixture of our stomach secretions. So we have acid. And remember, this is strong acid. This is hydrochloric acid. So we're not messing around here. We have different enzymes. So we have a new enzyme that we haven't talked about yet, and this is a protease. So protease is going to break down proteins. And then we're also going to have that lipase that we found in our saliva that's going to help us to break down fats. We're also going to have mucus, so we need to think about keeping things lubricated, as well as water, which is going to help that to be lubricated and also to keep things moist and to provide some extra liquid to keep things in solution. And then, of course, we have our partially digested food at this point. So remember, when it actually enters your stomach, probably not a lot of digestion chemically has happened. It's going to be mostly that mechanical digestion of having broken that food down into smaller particles. So your stomach is a fairly large sac. You know, we found it was 8 inches long when I did my little factoids, but it's about the size of your fist when it is empty. And that's not very big if we really think about that, but it can stretch. So we can see that it can hold up to 4 cups for several hours. And different people have different size stomachs. So little kids have little stomachs, smaller adults are going to have small stomachs. People that regularly overeat can actually stretch their stomach. It will probably come back because it's muscular. But we also have stretch receptors that sometimes get a little bit uncalibrated so that we actually don't notice when we're as full as quickly. So you can see that we have the ability to expand as much as 40 times its original size in order to hold a big meal or large fluid intake. So that stomach can really stretch to a much larger amount. Now we probably, if we're really thinking about doing this well, it's probably best not to ask our stomach to stretch that much all the time, but it can certainly do that. So we're going to find that this concentration of stomach acid increases as food enters. So, if you've ever, not had food for a while, but you've smelled it and you're like, oh, I really want food, I'm really hungry, you might kind of feel that acidity in your stomach. But because that acid starts being produced at least in small amounts early, but it's not until food actually reaches your stomach that we get that signal to really increase that acidity. So let's find out a little bit more about stomach acid. I mentioned that it's hydrochloric acid, which is a very strong acid. If you've ever taken a chemistry class, you know that hydrochloric acid is the stuff that you wear gloves, you wear goggles. If you spill it on anything, it will eat right through everything. So again, that just really points out how strong our stomach lining needs to be to contain that hydrochloric acid. Stomach is designed for it, but on either end, esophagus on the top end and small intestine on the bottom end, not so much. So again, we have thick layers of mucus that are really going to protect that stomach from acid. And your stomach is designed that way. Now we know that Things can sometimes go wrong, but for the most part, it works pretty well. One of the things that we really want acid to be able to do is it destroys the activity of protein and starts to denature it or break it down. And you might have experienced this if you've ever taken like a piece of fish or you've made ceviche with shrimp and you squeeze some lemon juice on it or lime juice or put some vinegar on it, you notice that that fish will start to cook and it actually changes the protein structure. It doesn't obviously cook, but it does the same thing as heat would in terms of starting to change and break down that protein structure. So that's really why we want that really strong acid in our stomach, is to begin to break down those proteins. Different proteins break down differently. So we're going to see that fish breaks down much more easily than chicken. Cow and beef is actually pretty hard to break down. It's more challenging. So we're going to see that in terms of how quickly things digest, it takes a whole lot longer to break down beef than it would a piece of fish. Vegetable proteins also break down pretty easy. We're also going to see that we are going to start to activate those digestive enzymes when there's acid present. So we're going to have those proteases and lipases that are going to continue to help us to break down that protein and fat. And we're going to actually do pretty well. We're not going to completely break down our dietary proteins, but a lot of what we're going to have happen is going to happen in the stomach. Now, before I go to calcium, I do want to mention that we haven't really talked much about carbohydrates. We talked about proteins and maybe some fats, but you're going to see that carbohydrate foods, our breads and our pastas and fruits and things like that, that don't really have much protein component, very little is actually happening in your stomach. We're also going to see that that acid is going to help us to absorb calcium. It kind of gets it ready for absorption. So nothing is actually happening absorption-wise in the stomach, but we're getting that calcium ready so when it hits that small and large intestine, it can be absorbed much better. So we're going to see that people that don't produce enough acid may actually have problems digesting and absorbing calcium. Other minerals as well, so not just calcium, but a lot of our minerals, it kind of helps to make them more soluble for that absorption. So again, very little absorption of nutrients in the stomach. There's one, and it's not really a nutrient, but there's one thing that we can actually absorb well through our stomach, and that would be alcohol. So just kind of keep that in mind, that that's one of the challenges that we have, especially if we don't have a lot of food in our stomach and we're drinking alcohol, we're going to have that absorbed much more quickly. But aside from that, there's practically no absorption of nutrients in our stomach. So I said the exception was alcohol. The other thing that we have in our stomach is going to be a substance called intrinsic factor. An intrinsic factor is a compound that's produced by our stomach that helps us with B12 absorption. And without intrinsic factor, we don't absorb B12 well. And certainly things that happen that, go wrong with our stomach can influence intrinsic factor, but also as we age, we produce less intrinsic factor, which is one reason why many elderly people have to take B12 injections, because they just can't break down that B12 from either foods or supplements. Now, so far we've talked all about chemicals, and that's what most of the action in our stomach is going to be, is either enzymes or acid, but we actually get some mechanical action. And I started the lecture talking about the muscle structure of our stomach, and so there is actually some churning. We're going to have things mixing around, not a whole lot of really major mechanical action. The mixing is more just to keep things in solution and in contact with our acid and our enzymes, but there is going to be a tiny bit of breakdown from that mechanical action as well. So that is the stomach.